In example 1, we're talking about a shipping container is in a shape of right rectangular prism with a length of 12 feet, width of 8.5 feet, and a height of 4 feet. So basically it's just a box with these dimensions. The container is completely filled with contents that weigh, on average, 0.25 pound per cubic foot. So this right here, as soon as I read this, this is the density. And I know it's the density because of the units. Because it's pounds per cubic foot, that means density to me because it's the mass or the weight, which is the pounds per volume. Volume will always be in cubic feet, inches, something like that. We want to find what is the weight in pounds. So that means we're looking to find the mass of the contents in the container. So if I know the density and I want to find the mass and I know the dimensions of this box, that means I can find the volume and I know the density, and then we can use the density formula. So I'm going to go ahead and find the volume first. So volume of a rectangular prism will be length times width times height. So the volume will be 12 feet times 8.5 feet times 4 feet. So that'll give us 408 cubic feet, so feet cubed. And then, so there's our first step. The second step is going to be to find the weight, or the mass. So in order to find the mass, we're going to use the density formula. Some of you remember the triangle from science class. Basically, the triangle is just whatever you're trying to find, you cover up. So in this case, I would cover up the M. And what I'm left with is D times V. So mass is equal to density times the volume. If you look at your equation up here, it's the same thing as me saying density equals mass over volume, putting this over 1, and then cross multiplying. And I would get mass equals density times volume. So it's the same thing. So if I'm going to find the mass, I'm going to take the density that they give me, 0.25 pounds per cubic foot. I'm going to multiply that by the volume, 408. And when we do that, the cubic feet would cancel out, and my units would be left with pounds, and it's going to be 102 pounds. And that's it for that one. So then if we move on to the next example here, it's talking about a contractor needs to purchase 500 bricks. The dimensions of each brick are 5.1 centimeters by 10.2 by 20.3 centimeters, and it gives us the density. Knowing the dimensions are going to allow me to find the volume. So based on what we're trying to do here, let's see, the maximum capacity of the contractor's trailer is 900 kilograms. Can the trailer hold the weight of the 500 bricks? So because we're trying to figure out can the trailer hold the weight, I need to find the weight of the 500 bricks. That's what our goal is. Find weight of 500 bricks. In order to make the conclusion, I have to know, does the 500 bricks weigh more than 900 kilograms? Because if so, then the trailer can't hold them. So if I'm going to find the weight of the 500 bricks, that means that I'm going to need to know the mass of one brick so that I can multiply it by 500 to get the weight of all 500 bricks. I'm also going to need, if I'm trying to find the mass, I'm going to need to know the density and the volume. Right now we have the density of the brick, so we're going to have to find the volume. So our first step is going to be to find the volume of one brick. So I'm just going to draw out one brick here. So the dimensions are 5.1 centimeters by 10.2 centimeters by 20.3 centimeters. So this isn't drawn to scale, but it really doesn't make a difference here for the purpose of finding the volume. One thing that I do notice, so when I'm looking at this, is that these are given in centimeters, and my density is in meters cubed. So the fact that the density is in meters cubed tells me that I'm going to need my volume to be in meters cubed. So I'm going to go ahead and convert these. And I included this chart over here to kind of help remind you how to convert. So this is something that you would have learned in like middle school science. Um, but King Henry died unusually drinking chocolate milk. I'm not sure if that's the acronym or the wording you used. But basically, centi, if I'm starting at centimeters, so if I'm starting here and I need to convert these to meters or unit, that means I need to go backwards here. So I am going to follow this rule right here, which is divide the numbers by 10 for each grid here. So really I'm dividing the number by 100 or moving the decimal 2 places to the left. So what's going to happen is this will become, so if I move it 2 decimals to the left, it'll be 0.051 meters. Move this decimal 2 places to the left, 0.102 meters. And move this 2 places to the left, 0.00203 meters. Now remember, you can also set up proportions if you'd rather do that and just know the conversion. 1 meter is 100 centimeters, but a lot of you like the acronym, so you can use that as well to help you. So from here, to find the volume, since it's just a rectangular prism, it's just going to be length times width times height. So I'm just going to go ahead and multiply these numbers in meters. So when I do that, I'm going to get a really small number, 0.001056006 meters cubed. So that's the volume of one brick. If I want to find the volume, or if I want to find the weight of 500 bricks, the next thing I need to do is find the weight of one brick, and then I'm going to multiply that by 500. If you wanted, you could find the volume of 500 bricks, but then you got to use the density of 500 bricks. So you might as well just do everything with one brick and then multiply it by 500. So next step, now that I know the volume, I'm going to find the weight of one brick. So to do that, if we want to know the weight or the mass, and we know the volume and we know the density, we're going to use our density formula. So our density formula, or your density triangle, so if we're trying to find the weight, we're going to cross off the m, which means we're multiplying. So mass equals density times volume. So mass is going to be the density, which was given to us up top there, was 1,920 times the volume, which is what we just found. And this was in meters cubed. This was in kilograms over meters cubed. So the meters cubed will cancel, and our answer will be in kilograms. So 2.02753,152 kilograms is the weight of one brick. So if we want to know the weight of 500 bricks, we're going to take that and multiply it by 500. So take this 2.02, and notice I'm keeping all of these decimals because we don't want to round too soon. And we're going to times that by 500. So we get 1,013.76576 kilograms. So that means the weight of all of the bricks is going to be 1,013.8 kilograms, but the trailer can only hold 900 kilograms according to the problem. So the weight is going to exceed the trailer's weight limit. So to answer it, you got to make sure that you actually write a conclusion. and answer the question and make sure that you explain. So therefore the trailer cannot hold the weight of the 500 bricks because the 500 bricks weigh approximately 1,014 kilograms, and the trailer can only hold 900 kilograms.